So that seemed to be 20 grams, but I'm needing way more. I needed 50. So today I want to make a precursor to polymers, and therefore I first need to weigh up 50 grams of fumaric acid, which I have here. So fumaric acid is pretty easy to get. It's just something you add to food, and it's non-toxic, and it's already a good starter for polymers, especially for polyesters, but I don't want to make any polyesters today. So that's not the topic of today. The topic of today is make a precursor for various plastics like acrylic glass or even polyacetylene, but you'll see soon. So at that pile here, there are 50 grams of the fumaric acid. They now have to be transferred into here, and I have to go and look for a funnel. So what I'm planning to do today is making the monoester of fumaric acid and the monoethyl ester in particular. So that means that one of both carboxyl groups are esterified. So I'm probably going to add some chemical schematics at the end. You'll see that. I think it clumped. There was actually quite some work getting all this through. So since I want to make the monoethyl ester, so after having added the fumaric acid, I'm going to add a bit of water absorbent. In this case I'm using dry magnesium sulfate, just regular magnesium sulfate fertilizer I've cooked on the oven, and I'm going to add about 8 to 9 grams of that. So I've calculated that it should absorb the needed amount of water that's formed during the esterification, and therefore driving that reaction to completeness. So there are 10 grams. Guess that's a bit much. There are 8.73, that's perfect. So I've added now the water absorbent. The next thing that's going to be added is some catalyst. So these catalysts are called cation exchangers, meaning that they have hydrogen groups like hydrogen plus, as you have on every acid. For example, on the fumaric acid as well. But the other part, so what's called the anion, I think, that is bonded to a polymer, so it can't move apart. And that means that you have an acidic solution, but the acid is bound into the polymer, only the H plus is running around inside. So I'm going to add a little bit of this catalyst here. I've dried them before the video because I want to keep water out of this reaction. So the last thing we finally need is ethanol. And for that purpose we need 25 moles, or I need 25 moles because I'm doing the synthesis, and that is dried ethanol. I've dried it overnight, and I'm measuring out roughly 25 milliliters here. That's a bit of an excess, and let's add a bit more. I think it was too much, but who cares. Then we have some diester as well, but it's only needed that it's more or less accurate. So the aim is to create the monoester and not the diester. And the way it can be controlled is by varying the ratio of both. So apparently it seems that this is a bit stuck. So maybe I can get this around by shaking. So, some kind of problem here. So that's definitely not enough alcohol. So there's still powder floating around. And since you can't melt down fumaric acid, it looks like I'm going to have a problem. So what I think I have to do is add in a solvent. But I can add more alcohol, of course, because then I would create more esters. So I need to add a solvent that does not react. The only problem is, I don't know what. I could add acetone, but I think its boiling point is too low to drive the esterification forward. Can add glycerin, can add propylene glycol, can add glycol. Oh, it's kind of difficult. I hate this. Maybe I should just try to heat it in the condition it is and wait for the ester that forms to melt down. So I think I'll just give this a stir. So this is all starting to get crappy now. I haven't tested the acid if it's in its hydrated form. I don't even know if fumaric acid has a hydrated form, but I'm going to do the following. So I obviously have no solvent. I obviously can't set this on the hot plate directly because there is not much alcohol in it to keep the temperature at the boiling point of alcohol under reflux. So I'm really endangering just cooking all this to death in here, just charring it away. Of course I have no hot plate with control. So what I'm going to do is I'm preparing a water bath and then I'm going to create the ester inside. So there it goes, DIY distillation resuck apparatus, and inside of course you see here the Elmar flask with everything that has no direct contact, meaning that there will be a lot of bubbling due to the heat and the boiling of the water, and this won't make this thing here jump around, so there's always some space, so this really prevents the flask from breaking apart, so to say. So I'm turning this here on a level 122, and now it's time to wait, see what's happening. And of course I'm going to turn reflux on. Maybe I have to point out one or no, two more things. First, this water bath makes a very much better heat transfer, so the whole reaction is going to be faster. And the mono ester of fumaric acid melts at 67 degrees Celsius. So it will definitely melt in here and act as a solvent, hopefully. So it's a bit noisy here, but unfortunately not too much ester was created, so there was no melting phase. Therefore I added acetone now, and I'm hoping the solvent will get the esterification done, because ethanol dissolves well into acetone and fumaric acid probably does too, and therefore it can easily react. Hopefully, we'll see later. That's what seems to be left from yesterday's esterification. So unfortunately, magnesium sulfate as drying agent is a bit poor, because it just clumped together and I couldn't really remove either the catalyst or the drying agent. So let's see what the distillation results. I think there won't be great results, but let's see. So the acetone starts to boil right at the moment, and soon there will be a vapor front rising up as the wall of the flask gets hotter. The vapor won't condense anymore. Finally it will make it through the distillation. Turned out to be rather a quick distillation of acetone. Last time I tried to make monoethylfumarate using impure alcohol, using wet catalyst, using wet magnesium sulfate, which is a bad drying agent, and using wet well, at least I guess it was wet fumaric acid. So this time I'm doing a bit different. So I'm going to use dry silica gel, which has been dried in the oven at a temperature of 120 degrees Celsius. This time I'm going to use dry catalyst, which has also been dried at 100 degrees Celsius, 120 degrees Celsius in the oven. I think it's still a bit wet. Oh no, please not. So at least there's some catalyst in. Maybe you can see it somewhere on the bottom here. It says orange goop. Here the catalyst is not perfectly dry, but there's always some catalyst left that isn't perfectly dry, but maybe I'll dry all of my catalyst later. So the fumaric acid seems to be perfectly dry, since it's fluffy again. It was always some kind of sticky. So I again go with 50 grams of fumaric acid, and it goes through the funnel by itself. I'm amazed how much water there was actually in the original fumaric acid. So I should have dried it before. So I won't yet. So I've gone. Oh no. So I've added everything. I've added silica gel, I've added catalyst, and I've added fumaric acid, and all of this is dry. So the catalyst is actually extremely sour and acidic ion exchanger resin. So it's like sulfuric acid you add to esterifications, but it's just a bit, let's say, better because it doesn't leave your residue since you can filter it out. And I'm going to add a lot of ethanol. So this ethanol will be reactant and solvent at the same time. And I hope it can dissolve all the fumaric acid. This is distilled, purified ethanol. And it should be absolutely pure and water-free. I really did my best with the synthesis to get only high-quality chemicals in the beginning. So the diethyl ester of fumaric acid, I suppose it to be, at least I know from the data sheet that it's a liquid at room temperature. It's pretty much insoluble into water, and it has a boiling point of around 200 degrees Celsius, so I guess I'm not able to distill it over, since I don't know if the apparatus is able to manage the temperatures. But at least, here, that's smelling like pure alcohol here. At least we should later be able to separate it using water. So I hope the fumaric acid does dissolve if the temperature rises. I have no idea how soluble this is actually in ethanol. There were no data. Try it out under reflux. And there it goes. Hopefully that works all out as expected. If so, it would be great. Amazing. This esterification takes a longer time, I assume. So in the internet, I did some research. It takes up to, here you can see the vapor front actually. So this is rising upwards here, and underneath the vapor front there won't be any more condensing there. It will be just boiling hot, and above the vapor front it's cool as ice. And you can watch this rising upwards, and then you see how far the vapors travel actually. But here it's reflux, so it's not that interesting. So I wrapped all the joints with electrical tape to prevent any alcohol vapors or ester vapors from getting out, so that it's really tight. Of course, these reactions do need some time. At least I heard 4 hours, but I probably let this run for 6 hours or maybe even for 10 hours. So I don't want any leakage. Apparently the solution gel works that's hot, works as some kind of boiling stones inside there. And I hope the fumaric acid gets dissolved, but I'm pretty confident. Ha! Even after 4 hours of continuous cooking, nothing happened. No yeast is created, so I guess it's not that there was water in. I guess it's not because the alcohol was impure. I guess it's because this cation exchanger, this sour catalyst, does not work. So if the internet says there is some way to conduct synthesis environmentally friendly and safe, there is no. Like Grant Thompson, what did we learn today? Well, this doesn't work. So I always already suspected this to happen. So I have some sulfuric acid here. Concentrated, of course. Goopy shit. So, in case there's something going wrong, I put on my face mask and let's insert a few drops. That should be right enough, and back on the fire. It worked, you see, it's transparent. So there's the silica gel inside and what I consider to be catalyst, so this is actually garbage, I won't use it again. But the silica gel, I don't think it's a very good drying agent, but at least it's a good boiling stone. So I think I am going to include them into further projects. So now this is all filtered off, so the silica gel and the bad catalyst, using a piece of paper, and then I'm about to separate off that ester. Around 30 degrees now and pretty cold, so I think I'm going to filter it now. I always was afraid that there is layering happening or that it might crystallize out, but apparently the data from the internet seems to be... So there you can see the bit of fumaric acid that came out after an ice bath. And now I'm going to filter this through a piece of paper. Hopefully with success. So here we are after I threw out the ester with water. So the water above does contain all the alcohol and the sulfuric acid catalyst, while on the bottom you can see the ester, and it's quite heavier than water.